Binomial probability distribution. Let's start by talking about a Bernoulli trial. It's named after James Bernoulli, who researched them at the end of the 17th century. And let's start with an example. So suppose we toss a fair coin repeatedly. Each toss is a trial. For each trial, the probability of getting heads is 1/2, 1/2. And this probability doesn't change from trial to trial. So these types of trials where the probability doesn't change are independent. When there's only two outcomes, they're called Bernoulli trials. So in a Bernoulli trial, there's either a success or a failure. And the random variable, this is important, always defines a success. So the probability of a success is P, and the probability of a failure is Q. So when you add them up, those need to equal 1. Now let's take a look at the characteristics of a binomial. So first off, a binomial experiment consists of counting the number of successes in one or more Bernoulli trials. So they need to be Bernoulli trials. The random variable x is always equal to the number of successes. N is the number of trials. P is the probability of a success on any trial, and remember that each trial is independent. If we take a look at the notation, so the random variable x counts the number of successes, and x takes on values of numbers, 0, 1, 2, 3, 4, all the way to n, whatever your n is. X follows a binomial distribution with parameters n and p, and we write this, and we read this right here, as x is a random variable with a binomial distribution. So the parameters are n and p, where n is the number of trials, p is the probability of a success. So here are some formulas that we will use. We'll also rely heavily on our calculator for this. So the mean, mu, equals n times p. The variance, omega squared, is n times p times q. And the standard deviation is the square root of npq. All right, let's take a look at some examples. So at ABC College, the withdrawal rate from an elementary physics course is 30% for any given term. This implies that for any given term, 70% of the students stay in the class for the entire term. So let's figure out what a success would look like. So a success would be any individual who withdrew. And we would let the random variable x equal the number of students who withdraw from the randomly selected elementary physics class. Let's take a look at another example. Suppose you play a game that you can only win or lose. So the probability that you win is 55%, lose is 45%. Each game you play is independent. So this is a Bernoulli trial. If you play the game 20 times, write the function that describes the probability that you win 15 of the 20 times. So the first thing we are going to do is we need to define our random variable x. X is the number of wins, so x takes on the values 0, 1, 2, 3, all the way to 20, and that should be an uppercase X. The probability of success, remember, is the P. Probability of success is 0.55. The probability of failure, which we represent as Q, is 0.45. They've given us all this information. The number of trials, N, is 20. And the probability question stated mathematically is P x equals 15.